Hello friends, today I am going to discuss about a random signal theory. We know that the input of the communication receiver is signal or noise. These two are the input of the communication receiver. The noise, we know that we cannot represent in mathematical way. So probability concept will comes into the picture. So random, but to analyze a random variable we need two function. To analysis random variable, let us assume x, two functions are needed. First, probability distribution function, which is denoted as f, capital F, and second, probability density function, small f. Then first, capital F x, that is known as probability distribution function, is defined as probability of random variable x is less than or equal to x1. Let us take one example. If we throw a simple dice, then what the chances? That means if x is a random variable, then probability of x is less than or equal to x. One, 2, 3, 4, 5, 6. Then probability 1 by 6, 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 1 by 6. That means 1 by 6 plus 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 1 by 6 is equal to 1. Probability always 1, we know. Then how to draw the probability distribution function? How to draw probability distribution function? This is random variable x, 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6. 1, 2, 3, 4, 5 and 6. This is the chances. We know that 1 by 6, at 2, 2 by 6, at 3, 3 by 6, at 4, 4 by 6, at 5, 5 by 6, at 6, 6. That means probability distribution function always increasing in order. Now probability density function, f of x. How to draw? Probability density function graph will draw like this: 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and area always 1 by 6 for all. This is the now evaluate the value of, if we want to evaluate the value like f of 0.2, what is the value for f of 0.2? That means probability x is less than or equal to 0.2. 0.2 will come here, 0.2 will come here. That means what is the probability for occurring 0.2 equal to 0, and what is the probability for occurring 0.99 equal to also 0? But probability x is less than or equal to 1 equal to 1 by 6. Probability x is less than or equal to 1 by 8 equal to probability x is less than or equal to 1.8. 1.8 means here that will also 1 by 6, but probability of x is less than or equal to 2 equal to 2 by 6. Now properties of the probability distribution function. Properties of probability distribution function. First, probability distribution always lies between 0 to 1. Second, probability distribution function is always increasing order. Third, if we want to calculate probability x is greater than x1, then how to denote it? 1 minus f of x1. Fourth, probability x1 x2 equal to PDF of x2 minus x1. Now second, this is all about probability density function. Now probability distribution function. Now second, probability density function. Probability density function, which is denoted as small f of x. F of x is equal to differentiation of capital X. This is the definition of probability distribution, probability density function. And then properties of PDF. Properties of PDF. First, area becomes always 1. Second, that means total area equal to 1. Second, probability x is less than or equal to x1 is equal to f of x1 equal to minus infinite to infinite f of x dx minus infinite to x1 minus infinite to x1. Third, probability of x is greater than x1, 1 minus f of x1, or x1 to infinite f of x1 dx. Fourth, probability x1 x2 x1 to x2. Then how you can denote x1 to x2 small f of x dx. Now second point, statistical averages. Statistical averages. First, mean or average value. We can denote it x var e of x or m1, that is defined minus infinite to infinite integration of x pdf dx, or dc value or dc component. In digital, this is for continuous and this is for discrete. Summation xi, probability x equal to xi. See, summation I xi, probability of x equal to xi. This is for discrete system. Second, mean square value equal to, this is denoted by m2, x1 bar का whole square, mean square value e of x square equal to m2 equal to minus infinite to infinite x square f of xx dx, which is called as total power. Total power. For discrete system, sigma I xi का whole square, probability x is equal to xi. This is for discrete. Third, variance. Variance, sigma whole square e of x minus xy का whole square equal to m2 minus m1 का whole square. This is known as AC power. This is known as AC power. That means total power is equal to AC plus DC power. AC power sigma square plus DC power m1. That means m2 equal to sigma square plus m1. AC total power means mean square value equal to AC power in variance plus m1 mean, or sigma square is equal to variance is equal to m2 minus m1. Fourth, m1 का whole square. Fourth, standard deviation. Fourth, standard deviation equal to root of variance equal to under root of m2 minus m1 का whole square, or root of AC power or RMS value of AC component, RMS value of AC component.